Have you ever noticed steel plates welded inside beams or columns and wondered why they are provided? Stiffener plates are important structural components used in steel structures to strengthen members and improve their load-carrying capacity. These plates help prevent local buckling, distribute concentrated loads, and improve the overall stability of beams, columns, and connections. In this video, we will understand what stiffener plates are, why they are used, the different types, and where they are commonly applied in steel structures and PEB projects. Now let's understand exactly what a stiffener plate is and how it helps a steel member carry loads safely. A stiffener plate is a steel plate welded to a beam, column, girder, or connection to increase strength and stiffness in a specific area. Its primary purpose is to prevent local buckling, resist concentrated loads, and improve the structural performance of steel members. Stiffener plates do not usually carry the main structural load themselves. Instead, they help distribute forces more effectively and strengthen critical locations where high stresses occur. These plates are commonly installed near supports, heavy load points, beam-to-column connections, base plates, and industrial steel structures. Let's learn why engineers provide stiffener plates and what problems they help prevent in steel structures. Steel members often experience concentrated loads, high stresses, and local deformation at specific locations such as supports, connections, and load-bearing points. Without adequate reinforcement, these areas may develop local buckling, web crippling, excessive deformation, or stress concentration problems. Stiffener plates are provided to strengthen these critical zones and distribute loads more effectively throughout the steel member. By improving stiffness and stability, stiffener plates help steel structures perform safely under heavy loads and demanding service conditions. Now let's look at the different types of stiffener plates used in steel structures and understand where each type is applied. Stiffener plates are classified based on their function and location within a steel member. Although their purpose is to strengthen a structure, different stiffeners are designed to solve different engineering problems. The two most commonly used stiffener types are bearing stiffeners and intermediate stiffeners. Bearing stiffeners are used near supports or heavy concentrated load locations. Intermediate stiffeners are provided between supports to improve web stability and prevent web buckling under shear forces. Both types improve strength, stiffness, and structural safety. Let's understand how bearing stiffeners help steel beams safely transfer heavy loads to supports. A bearing stiffener is a vertical steel plate provided near supports or locations where heavy concentrated loads act on a beam or girder. When large loads are applied, the beam web alone may not be strong enough to resist the resulting compressive forces. This can lead to web crushing, local yielding, or deformation near the support. Bearing stiffeners strengthen the web and help transfer load safely from the beam flange to the support structure. They are commonly used under heavy equipment loads, crane beams, transfer girders, industrial structures, and heavily loaded steel members. Now let's understand how intermediate stiffeners improve web stability and prevent buckling between supports. An intermediate stiffener is a vertical steel plate installed between supports along the web of a beam or girder. Unlike bearing stiffeners, intermediate stiffeners are not primarily used to transfer concentrated loads. Their main purpose is to improve web stability and prevent buckling caused by shear forces. When a beam has a deep and slender web, shear stresses can cause the web panel to buckle before the member reaches its full strength. Intermediate stiffeners divide the web into smaller panels, increasing its resistance to buckling and improving overall structural performance. They are commonly used in plate girders, bridge girders, crane girders, industrial structures, and long-span steel members. Now let's see where stiffener plates are commonly used in real steel structures and PEB projects. Stiffener plates are widely used in steel structures wherever additional strength, stiffness, and load transfer capacity are required. In industrial buildings and PEB structures, stiffeners are commonly provided at beam-to-column connections, crane girder supports, base plate assemblies, and heavily loaded members. They are also extensively used in plate girders, bridge girders, transfer girders, and equipment support structures where concentrated loads or high shear forces occur. By reinforcing critical areas, stiffener plates help improve structural performance, increase safety, and reduce the risk of local failure. Before using stiffener plates, engineers must consider several important design factors to ensure safe and efficient performance. The effectiveness of a stiffener plate depends not only on its presence but also on its proper design and detailing. Engineers must select the correct plate thickness, size, location, and welding arrangement based on the loads acting on the structure. The stiffener should be capable of transferring forces efficiently without creating excessive stress concentrations or fabrication difficulties. Proper welding, fit-up, and detailing are also important to ensure that the stiffener performs as intended throughout the service life of the structure. A well-designed stiffener plate improves strength and stability, while poor detailing can reduce its effectiveness. Let's quickly summarize the most important points about stiffener plates and their role in steel structures. Stiffener plates are essential structural elements used to strengthen steel members and improve their performance under load. They help prevent local buckling, improve load distribution, increase stiffness, and strengthen critical locations within steel structures. Bearing stiffeners are mainly used near supports and concentrated load locations, while intermediate stiffeners are used to improve web stability and resist shear buckling between supports. From PEB buildings and industrial structures to bridge girders and heavy equipment supports, stiffener plates play a vital role in ensuring structural safety and reliability. Understanding where and why stiffeners are used helps engineers create stronger, safer, and more efficient steel structures. If you found this video useful, don't forget to like, comment, share, and subscribe to ACP Civil Hub for more steel structure, PEB, and structural detailing tutorials.